Hello and welcome to our 49th podcast, which we could always, just refer to it as a vlog as well. I haven't done guests yet. I've been focused more on electric machines and different types of prognostic stuff. A lot, a lot of stuff in relation to generative AI, and there's been a reason for that. So the preview of what we're going to discuss after I get up my soapbox is how to take a little device like this, fits literally in my fist, and test electric machines as large as hydro plants and just massive devices with current clamps is like this, which is anything from 20 to 200 amps. There's some I have that will do just straight 5 amps. I prefer this one because then I can get some overload data. DC Rogowski, DC Hall effect probe for DC machines, or smaller current clamps. This one goes up to 400 amps, or 1,000 amp clamp. Something I can buy off of Amazon or pick up at a store that sells test equipment, or even this one, which is my 6,000 amp Rogowski coil. I could go up to whatever size I want. Basically, no limitations on it, but in a device that fits in my fist. Now, I'm breaking a lot of rules, and those rules include that I have to make this big enough to do whatever. So, and we're also, I'm not going to phones and iPads and stuff like that at this point, because everybody goes there. And no, this will still be on a PC right now, PC or laptop, like this laptop here. We're going to focus on those first. I can always switch it over to a phone. Actually, the way we did it, I could switch it over to a phone app, in days, using the methodology we approached. Now, over the last couple of years, I've seen a lot of people refer to themselves as AI experts and et cetera, et cetera, et cetera. And, worse, I've seen stuff about, the famous ChatGPT, which I am a fan of. But it seems to be that thing these days of overpromise and underdeliver, in that everybody's going in saying AI is going to solve all your problems and replace your entire workforce, et cetera, et cetera. So let me start with a book that I ran into recently. And what you do is you put AI in the title so that you sell a lot. The minute I put AI in there, let's just say we're living the age of Dilbert now, in which sales and marketing runs around and says, we're going to violate the laws of physics, and the customer says, great, here's the contract, and the engineers go, wait, we can't violate the laws of physics, and then that way that they get blamed for all the problems. I've been seeing a lot about how it's going to replace jobs. I've seen people get on stage talking about, how AI can do all these wonderful things for you and your data, and it can. However, the impression is being given that you can eliminate expertise. Well, the exercise we just went into using not the free versions of anything, and no, I'm not going to the commercially already biased systems by all these other folks. No, we designed something from scratch using generative AI that we are using as a commercial product. But I'll explain a little bit more. It's not really generative AI. That was our basic stuff, the actual algorithms and capabilities and details of the system still had to be done by humans, because I'm sorry, no matter what people say, because now apparently you can talk to ChatGPT on your phone, and it sounds human, just like Alexa and all these other toys did, Siri and everything else. They're pre-programmed responses or trained responses. It's not an intelligence. You're not talking to anybody with an IQ of anything. There is no IQ there, regardless of what everybody wants to tell you. And it's machine learning. People keep calling it AI, and then now it's called the next level of AI. And I think now they're so what used to be AI, which is a thinking conscious computer, has now devolved into the term AGI, but now AGI is being taken over from a marketing perspective to push the next thing. So out of the book, I thought, when I started reading it, because I actually read it, all this stuff back here, that's not for show. I've read every one of those. The danger of AI may not be in a technology that develops a will of its own. This is true. The real danger, it would seem, is that humans will simply believe anything the machines say, no matter how wrong. That is unbelievably true. I can see that in social media every minute of every day. I see these things pop up in their obvious generated images and videos of stuff that just simply does not exist. And everybody goes, oh my gosh, where do I invest? So our biggest danger right now is that there's that thing about when they talk about average intelligence, that means that 50% are below that level. People have a tendency to believe what they're trained to believe, and I went through this book even, and here's and it's by a couple of sales folks that I've followed in the past. I mean, I've had sales positions, and I've had to go through and kind of learn some tricks of sales. And I tell you what, sometimes it just was outright disgusting. Other times it was, okay, this is a process I can believe in. I won't lie to a customer. I mean, it makes no sense, because then you have to cover that up. You spend more time doing that. I'd rather be honest and truthful up front. So this is a Wiley Press book, and Wiley Press is a technical publisher. I went through, and I do work a lot with generative AI, and it pushes the thing, and it goes into prompts. And it says, oh, yeah, when you want to know something about a customer, or an industry, you prompt it, okay, I've got a discovery meeting coming up, and da-da-da, I need to know something about this industry. And then they show the examples of the phenomenal results they get. And I looked at these and I went, these are generic things. These are not specific to that particular whatever. It just looks good. So in their own book, after warning you that you were going to believe anything, they believe stuff. And they do one on a particular industry that I'm very familiar with, and it wasn't close. So things that those are things you have to be aware of. Now let's get into the technical end. Now, why I said I break rules is because MotorDocAI, I mean, I've done the corporate consulting for implementing reliability programs and maintenance programs, and I've won awards over it from General Motors, corporate and other things. I've done all these other things, and I decided after 2009, following down with everybody else, the one thing that survived through all of that was what I could do to solve technical problems. Okay, that means electric machines, equipment issues, things like that. And I'll do two things. One is I enjoy dealing with the individual equipment, but I'm a systems engineer. I look like looking at the entire picture, which is part of what makes my team really good at doing root cause failure analysis and stuff like that. 9 times out of 10, we walk into a situation and everybody's focused on that little pin prick of a problem, the actual effect of the actual defect, instead of identifying what happened back here that, led up to that point. And then we can go back and say, at what point can we break the chain of bad to eliminate that problem from happening ever again? So when I started looking at what could be done, I was working towards a couple of things. One of the rules that seems in the industry is figure out how to charge more for less. How to make things that should be simple very, very complicated to use. Don't know why. I think it's the idea that if I make this thing complicated, I'll buy it, or the customer will buy it and they'll put it on the shelf and they'll forget about it and I don't have to worry about it and I made my money. No, I want people using, if I'm going to create something, I want people using it and solving problems. So that was one of our goals, is taking this in an area that people are familiar with us for, because we do the empath electrical signature analyzer as well, which is a more complex system, but it does a lot of things that what I'm going to show you doesn't do from a power quality perspective, and a couple other things. Which leads into another thing. I read an article recently by a company trying to position themselves as a competitor, and I just about, I don't know. Every time I read them, I go, well, that explains a lot. In this case, they said current signature analysis, well, it kind of gives you an idea that something's going on, and it alludes to problems in driven equipment. And I'm thinking to myself, what the heck? I mean, we don't just, we pinpoint the defects in driven equipment. And whether you're using electrical signature analysis, which includes current signature analysis, or using straight current signature analysis, you're going to see the driven equipment defects a long way out. This company also claimed to have been involved in wind, and I go, well, that explains also why we don't see any competition in wind. Because we look at the entire system with electrical signature. But it means that there's a point where it's difficult to make it less expensive because of hardware. So when I was sitting there and I was like, I was literally at the Vibration Institute and I'm thinking, annual conference, and I'm thinking, how do I, we were talking about how do we make it easier for people to get equipment in their hands so they can start learning the technology, because electrical and current signature analysis is so far behind vibration. I mean, everybody settles that vibration is the be-all, end-all, and it does a lot. Ultrasound is coming up, because it's inexpensive to make. And I said, okay, well, I need to come up with a way to do this. And then this comes in parallel with challenges. Again, I'm going to go back to I'm going to go back to the ChatGPT thing and say, everybody keeps talking about, well, you can go in and you can, get new insights in your whatever by understanding the prompts. And I'm watching some of these presentations. Here's what I learned. Half the time the people say they're going to come and do the presentation, they promote the heck out of it, they don't even show up. Probably because they haven't invested the time. So I changed MotorDoc and MotorDocAI into a technical solutions company. I don't feel like competing with these companies that focus on the squishy stuff, the management level stuff, because when it comes down to it, when push comes to shove, what's the first to go? We learned that the hard way. I had major contracts, I had engineers, I had everything else, and then in 1 week, because Congress signed something that damaged the auto industry, it affected every industry we were involved in. U.S. Steel, General Motors, Amtrak, and some others that we had the contracts with. So I said, we're going to be technical. Well, as a result, no matter what's happened, people have to keep their equipment running. They need water. They need wastewater. They need, you name it. we end up involved in some way, shape, or form. We've also been doing a lot of machine learning and AI work. As a matter of fact, because you couldn't do much during 2020, I spent most of my time when I would travel to job sites working on projects for large international companies on developing AI systems to look at their SCADA networks. And I keep seeing all these companies saying, oh yeah, we do this and that. And then I find out, no, they don't. So today we're going to talk about what it actually took to take this little thing that we discovered at the Vibration Institute, combined with any selection of the current probes, to develop a software from scratch using Python. That we are now selling as a product. The first unit shipped 2 days ago, and that was specifically to work on the water supply to the suburbs from the city of Chicago. So I'm going to have that data come Monday to do a comparison. Empath was used and the Empower. So I call it the Empower, the electric motor performance optimization and recognition, waveform recognition. So the whole idea is, and I'll be blunt, I had ChatGPT come up with the name. It was kind of cool. I was like, oh, really? I like that word because I see it a lot. But the acronym was pretty cool. So, the electric motor performance optimization, waveform, and recognition software. So that's it. Let's talk about it. So I pull up, what I use is, I don't use the $20 version or whatever. When you use those, you run into a limitation on how many you can use. So we actually use a commercial version, the higher end one, where they don't use it to train their internal models. That's far more expensive. It also means, though, that I can have my teammates do it as well. Also can select which tool I want to use at this point in time. Canvas is kind of neat because what it'll do is it's ChatGPT 4.0, but for programming. So I'll be able to put my questions on the left, and it gives me a larger screen on the right. I always use a dark background because I'm staring at a screen a lot. These are still limited on the number of ones you can use per week. So as of today, it's updated again. So I can go back to using these because I use them up each time. Now there are additional things that you can do, but I don't need any of that stuff. Those work fine. I do run into things as I go through, and most of it has to do with selecting the right prompt or whatever else. There's also limitations. Okay, so when I passed the first 1,500 lines of code, where I was asking it to help me write the code using, I said this is what I want it to do, and then it would do whatever it wanted to anyways. Then I had to go back into the code and fix it. But what it did do is generate a format that I could work with. So I use a combination of ChatGPT, GitHub's Copilot, and which Copilot itself I use other IDEs, but for this project I decided to use the Microsoft IDE, right? So this is the Visual Studio coding. So it allows me to come in, and this is some of the code from what we've developed. So I came up with a format that I wanted. I decided to use Tkinter, and I used some basic libraries so that I would not run into a lot of problems. So there are no special libraries in what I'm going to show you. There's nothing phenomenal specific. It's all existing libraries. So everything in here is open source to develop. The algorithms and how it's analyzing data and the features of the software, that's very specifically mine. So my team on this programming thing, outside of some other people I used for reality checks within the organization, was myself, and I kept up my normal workload. So it was evenings and weekends like this. Today there's some additional features we're adding to the software, some cleanup we're doing, because the first units for end customers and distributors ship on November 1st, so a few weeks out. In the meantime, I've got beta users running around with the systems, testing it out, telling me, hey, if you could tweak it a little to do this or tweak it a little to do that, it would be awesome. So let's take a look at the actual software. And I'm going to go to the latest version because it's in development. This part's in development a little bit, so let me get this stuff out of the way, and I will show you a quick tour of the Empower version 1, because it's originally I told people it was going to be a beta version that we released. As it turns out, no, we're so far ahead of where we had planned. I'm less than 8 weeks out from the idea of finding the hardware finally. I mean, all the thought behind it I've been working on, but the actual hardware is what I needed. So I needed to know what kind of data I was going to play with, and it turned out pretty good. So, and then of course I'm using things that I'll be able to later transfer if I decide to make it a cloud-based system. So the decisions I made on the system was I wanted to be less expensive. Oops. I'm talking and I forget to type in a simple thing. Now I'm showing you the development version. Okay, so here we go. Nice, just very clean background. New analysis starts an analysis from scratch. I don't have an actual, the video and stuff and everything is connected through my USB, so I can't do that on here, but I've put stuff up showing that in action. Analysis. This is the Watt analysis portion. Also, save PDF, that's a report. This is an energy analyzer. It'll estimate. Now, the empath, the ESA, is going to give me very precise values in watts. This is accurate to within whatever it actually determines the current to be, and a couple other things. So, but it'll estimate load based on the current value versus the nameplate and what the exact frequency is, which makes it a little more accurate. Nameplate information, any rotor bars. Now this part you have to manually enter. The empath, it will automatically enter that and has a library. This does not. So you have to get this data and put it in. We will provide a spreadsheet that has the most common rotor bars and stator slots. Coupling and driven equipment. So this includes a belted application, gearbox application, its teeth and each bearing, and then pumper fan. Now, here's what we did. So part of the feature I wanted to make sure of, an update, by the way, will run this analysis based upon the findings back here. So if I'm on a VFD or I'm operating in a 50 hertz versus 60 hertz environment, all that is taken into account and passed to this one. Once I'm in here, say I have a belted application versus direct drive. So if I click direct drive, it's going to pass the speed from the motor directly to a gearbox or fan or pump, right? If I put in belted application, it's going to come here first, analyze the inputs and outputs, identify the slip, and then use the slip speed, meaning the actual output equipment speed, and apply it to if I select either of these. If I don't, it's just going to tell me condition of the belts and slip. And then I can select the gearbox or pump, that kind of thing. So basically, I'm compensating for all that stuff within the software right away. The other thing is this, and this is something I run into with false positives and the standard stuff. So these are my alert levels. This will be the millivolt per amp rating of the CT I'm using. The one that I send with the unit is this one, which covers a majority of machines for people, including, by the way, the high voltage machines, because you take the data off of the CT, right, that goes to the relay, basically less exposure and everything else. So I put all that stuff in here. Right now, this is going to default to this. It's not going to do either of these because I want you to have the accuracy necessary to test a machine unloaded, but a standard machine. This one here, it would take about 15 minutes to collect the data because I'm taking across the entire spectrum, versus what most of the ESA and current signature devices do right now is they take a much shorter spectrum, take a much shorter sampling rate, and everything else. And that's a problem that can't be solved with a standard method. As soon as I saw the new hardware, I contacted the OEM. I said, send me a bunch of these right now because I know exactly what I can do with it. Python is very good at handling sound. We'll just put it that way. So a lot of musicians use it. This down here is the stuff that we're going to use for the energy portion. And then this is key. So what will happen is if I have a noisy environment, sometimes my noise floor increases. Now, we do everything in current signature and electrical signature analysis in decibels down from zero, or the peak voltage or current, in this case, the peak current. And I'll show you what that looks like here in a second. Problem is, if I have a lot of noise, that noise floor might go from minus 100 dB and float up to minus 50 dB-ish. So all of a sudden now I'm going to get false positives on every one of these because I'm showing dB down, right? So what you do is you compensate for that shift. So one of the algorithms that I developed some time ago, we used in the software. We are using it in the software. And then each time I save the motor, it saves it. This is the sensitivity rating of the device, and I put it on the device so you don't have to go hunt for it. That is the save global bit. There'll be some other things we'll add later in, say, version 2. This is version 1. So the layout, the structure of the program was all done in ChatGPT. And there was a lot of things we ran into with this, and a lot of lessons learned. First, regardless of what every salesperson and marketing person gets up on stage or tells you on LinkedIn or whatever else, the only jobs threatened by this are the mediocre programmers. You need to be an expert. You need to know exactly what you're looking at. You need to understand the flow of the software. If you're getting anywhere beyond 1,000 lines, or say, okay, so I think I got up to 2,000 lines before ChatGPT said, nope, can't handle any more than that. Or whenever they get whenever they're under attack, they go and you try to put up a full copy of the Python code and say, hey, can you review my code for me? And it comes back and says you violated your terms of service by working on, basically malware or something. And it's like, no, I'm not malware. I am this. And then it goes, oh, okay, well, we'll review it. And then you can have access to your system again in a couple of days. Little setbacks. In any case, so So, things like that. The other thing was I had to understand what I was working on, meaning I'm working on current signature analyzer here. I had to understand current signature analysis. And as I mentioned in a previous version, I literally wrote the book on it. So, and actually the only book on it, there's another book on rotor bar testing and current signature analysis, written by Bill Thompson and Ian Culbert. It's a really good book. It's on my shelf as well. But this is what I used. This is based on all of the research I've done in 30 years of doing, almost 40 years of doing vibration and electrical signature, but 25 to 30 years of doing electrical signature. I'm losing track of time. I'm getting old. But in any case, and there's another lesson. That background, that knowledge was all required to get to where we were. So let's take a look. And because if you've watched my stuff before, this is going to bog down just a bit. So I may pause at certain cases to allow the software to run. Because the system I'm using to record eats up a majority of my CPU and RAM, and I've got 32 gig in this machine. So this doesn't require that. This will run on 4 gig of RAM and a medium, chip. So it doesn't need anything advanced or fancy. The faster your stuff and the less crap you're running in the background, the faster the software will run. So we're not going to do new analysis. Let's go ahead. We're going to open an existing set of data. This is a small motor in the other room. I'm not going to show you some of the other stuff. But let's take a look at this. This was from a few days back. So we're going to go ahead and open it. Now, in the background, and then this is the nameplate data. In the background, it's doing a bunch of stuff. Okay, so I accidentally forgot to put Python ahead of the name. Okay, so it's doing all the plotting and everything, and it's slowing down right now because this is where it needs a little bit more memory. There we go. It's doing all the plots. It's doing all the other work. I have a bunch of stuff in there because troubleshooting. The first couple of sets of software that go out, they'll have the window still open in the background. So if something hangs up, the testers can call me up and say, hey, here's where it hung up, because then I know exactly in the code where to go to. It also provides the ability, if I want some assistance troubleshooting or finding interactions between the over 10,000 lines of code I have in here, I can then go back to ChatGPT or even the other systems I'm using to help me do stuff. So here we go. So it's popped it up. For those who use Python, you'll recognize the navigation tools. That includes here as well. This will pop open the rest of the way here in a second. There we go. This is the kilowatt, watt and kilowatt analysis. So this is power in watts. It automatically shifted to watts because it's a small machine. And I can go in and zoom in on the values, all the way, say, down here. And if I miss it a little bit, I can scroll across and zoom in even further. Whoop. I did something there. Okay, let's try that again. I can move. There's a lot of work behind this stuff, right? So let's go back in here and let's take a look and see what's going on right at the beginning. So we're going to zoom tiny. So this is, some noise that's going on there. This is the running speed right here. These are 5-ish hertz sidebands of the running speed. and this is about 0.6 watts. Okay, so just over a half a watt. This motor is sitting there just doing whatever. That and the sidebands are the energy lost in vibration. So not a huge amount, but the motor is only about 10 kilograms and half a watt. So I come in here now. I have this. Well, here's critical. Everything in analysis comes from the speed. And so I tried a couple of approaches. Oh, and here's the other thing is where I set exactly where the tip of that pointer is. That's X is the frequency, Y is the dB down. I can do that down here as well. I can zoom all the way down because I'm 0.01 hertz resolution on these. Okay, so when I come in and I take a look at this, speed is vitally important. There's a small difference in the line frequency. It's 50.02 hertz. It's on a VFD. My VFD has a firing frequency about 2 kilohertz. That's the second hump or harmonic of it. It's not tuned, so it's pretty noisy. That's all deliberate. See how it works. And of course, it's an unloaded motor with a bearing issue. So let's go ahead and we're going to auto-analyze. And what I do is I have it, okay, so it's on the other screen. It pops up something saying, hey, this can take up to 2 minutes. And while I'm running this, I'm assuming it'll still take about 2 minutes. In the meantime, so right now, I on the scrolling, it pauses because otherwise it will show you every 0.01 hertz increment in the band below line frequency and above line frequency to hunt for my running speed, which is right here. But I've got to do it in software. By the way, those are those sidebands that were showing up on either side. Okay, so those are artifacts of some type. So it could take up to 2 minutes for it to finish running, and then it's going to populate this, and it's going to populate with what it's found. Now my noise floor, you'll see as I'm doing all right there. So my noise floor is about right. Noise floor is telling me it's just under minus 100 dB, so I automatically have it sized. So anytime it opens up, I don't have blank screen below or I have a lot of noise depth below. It's just going to start right at a few dB below the noise floor. The noise floor is the median of the average of all of this noise here, so that you always see this. For me, that's the way I always liked looking at it. Same thing here. This is small little bit down there. I'm out to 5 kilohertz here, even though my actual and analytical range can go out as far as 22 kilohertz. I'm just taking the 5,000 hertz snapshot, and it's 0.01 through that entire spectrum. But at about 10 kilohertz, I start seeing aliasing issues. Okay, I will go ahead and pause until it starts populating. Okay, so it's about to finish populating here. It came out to exactly 1 minute and 45 seconds. Once it's finished, right now it's calculating all of the lines it's going to put in to identify everything, each line for, stator related stuff, air gap related stuff, both static and dynamic, where it sees bearing related things, all of that. I've got cursors coming up for everything. So whereas, with a lot of systems, you have to go in and do your own calculations and everything else. So here we go. These are all of the different things. So the black ones are bearings. Yellow is speed, pole pass frequency. It blended in here, so it won't call anything. Yep, it didn't call anything because of the value that it has by going, blending in with my main peak. Because it's 0 dB down, therefore it's nothing. So I did that. That's how I get past the line frequency peak. If I'm running a synchronous motor, or in this case a motor that's operating at 50.02 hertz, this is running almost exactly synchronous. So the next thing I can do is come up here and say, okay, let's go ahead and analyze the load and everything else. So because of the conditions I have, it's thinking it's about 90% loaded. That's due to the harmonic content. It's not affecting the slip so much. This is the estimated energy and consumption to operate it for a year at its load and everything else. And this is the estimated annual emissions in tons of CO2. That's metric tons. So 1 metric ton is 2,240 pounds. And then this is the next 3 lines are basically, hey, if I have this particular condition, how do I, if I have this particular condition or these conditions, the unbalance and bearings and everything else, what's the total? And I just keep it in kilowatt hour, because majority of people are going to use this on motors larger than this. But I mean, heck, I have it set up right now so an HVAC tech could go up, and on a single phase motor tell you what's going on with your motor. So have all that. That's all there. There's the nameplate information and all the other data. I said 6,000 hours of operation and 14 cents per kilowatt hour. Okay, so here I am, and then if I come in here and I say, okay, let's take a look and see what all of these peaks look like. I go down to the bottom, I'll be able to scroll down a little bit. There we go. And so all of these are different things, different colors, identifying different types of defects and everything else. So that'll be all in the manual. But as I mentioned, and you can see running speed dead on. So it came up with this. I can say, okay, I don't agree with this, that, and the other thing. Winding stress, something we had discovered, and what winding stress indicates is that the drive, in this case, the VFD, is not, the parameters are not set properly. So all of this is built into the software. I mean, I can even, if I wanted to, dig in to see what the waveform looks like in current. Whoops. Try it again. Let's look at a couple of, so here we go. There's my current waveform. I can look at that. I can have this like this. When I have all this together, if I want to put anything here like, replace bearings and balance. Okay. If I don't put anything in, just say none. Save it. It's going to pop it up, and I'm going to call it new test 3. And then it will populate a report. And I did all of this in combination with, let's see if it pops up automatically or if I have to go in. Okay, it's going to make me have to go in. Let's see, what is... Okay, so I've got something somewhere. Here we go. My file explorer is I've got something going on in there, and wasn't letting me open my existing one. So let's go ahead, and I'm going to do it on this screen because you don't need to know, you don't need to see my structure. Okay, let me pause because this is hanging. Okay, so let's see how this turned out. So this is the first page of the report. And this is the second page of the report. You can see everything I had in there in line. So I could even, and by the way, that was one of the other things. I left that open so that you could type in anything additional. Ask AI assistant, what do you want? Okay, so something, oh, I scrolled up, so yeah, it's not where it should be, and then, so it's just grabbing that exactly, and then it's saying what I said, and then all the other related stuff. So not too shabby for a quick software. And then as I have everything else in there, that'll also show up in those results. So that we created again with generative AI. Used a couple of different tools with the focus being on ChatGPT as the main development engine. Not really the engine, but the main developing tool for putting it together. But once we got to a certain point, then I had to evaluate by function. Here's some of the things we learned. If you don't know what you're doing and you just blindly cut and paste, so I did some experiments where I said, you know what, I'm going to blindly cut and paste because somebody said, oh, ChatGPT is doing all the work. Nope. I took a couple of days, and if I had followed the path that it had me doing, which was take my functions and make sub-functions and sub-functions and sub-sub-functions, that kind of thing, it turned into a complete disaster. Some days it woke up on the wrong side of the bed, and I didn't give it a good cup of coffee or something, or it had a mood, or fight with its girlfriend or whatever. And in the end, it would just go off on some weird track somewhere. And so in those days, I said, okay, I shut it down, and then we just focused on going through the code. So I grab another person, and we just go through the code and make sure it flows right, see if we can find certain errors, bugs, features, things like that, and anywhere where we can streamline it, make it better, that kind of thing. For instance, one of the areas I really want to focus on is in my speed detection right now. I'm kind of limited by how quickly Python can iterate through that many points to then go back and figure, okay, so takes a point, says what's the highest peak here, Now I go back to all these peaks I've collected, and I say, okay, which is the largest peak? This one, that's my running speed. Not that simple. I do a lot more behind it, but that's basically the idea. So I'm trying to replicate what I do as a person, and basically what amounts to an expert software developed with machine learning and AI. Now, again, the algorithm portion and some of the other calculations, I won't trust the AI with that. It just simply can't do it, especially on something like this where there's not a huge background. Might do it on a vibration program. I mean, there's plenty of stuff out there that it trained on, but a lot of that has bias and some other issues. So, again, errors, hallucinations, all the things they warn you about, you absolutely need to know what you're doing as far as understanding the code, the structure you want, and everything else. And you need to be able to direct ChatGPT to do it. Now, back in the early days, in the very, very first version of 3.5 and 4, when I would type in a question, it's a chat bot. Okay, so it's literally a question and answer chatbot, and people forget that. It just uses a lot of data to create its answers. Well, I'll give you an example. Air Canada used it and ended up getting into a lot of trouble because it used it to replace people. And so when there was a question concerning whether or not a policy existed, it gave advice. That advice was bad, especially to a grieving family. So the advice was bad. and based upon what other organizations used in their policy, and it didn't go well. It gave some bad news, right? I mean, bad like media news for the company. So it becomes incumbent upon the people using this stuff is that you use it as a tool and a support and the ability to help you beyond where you are. We are doing projects. My team in MotorDocAI, which is I separated out from MotorDoc LLC, which is basically our front-facing technology and consulting arm. But MotorDocAI is a collaborative development organization. So we're doing work with real SCADA data, not the made up crap using MATLAB and stuff like that. As a matter of fact, my MATLAB licenses begin to run out for the last year, and I'm really tired of spending 15 or 20K for a tool that we no longer use. So it's going bye-bye. That kind of thing. Or I might use it as a tax deduction. I don't know. Well, we'll see. I have to make that decision today. But in any case, I have all these. You have all these new superpowers if you're a programmer, if you're a technician, stuff like that, to be able to utilize this if you know what to do with the data. You also have to be really careful with the data if you're using the free versions or even the $20 a month, and that price is probably going to go up, versions of ChatGPT and these other things, because it may take your data and actually train off of it, and then all of a sudden what you put in becomes available to everybody. Another thing to watch out for, and it's something that I had identified once before, and I scour the code for code that shouldn't belong. Okay, so that's part of our mission when we go through all these lines of code, is did it insert something I don't want there? So in a number of cases over a period of time, somebody thought it would be a great idea to insert ACE tools into every time, try to call ACE tools buried in the software. So in the beginning of a Python, you call all the libraries you don't want to use, and then you use them, but it would try to import and install and then run ACE tools embedded in the software. ACE tools is a hacker library. You don't want to have that on your computer, for one thing, especially, you don't want it there. It throws up a couple of flags, that kind of thing. It's basically penetration test tools. That's how it's touted, but in reality, it's the stuff that all the bad guys use, all rolled up into one library. And let's see. That's basically it. What in the end, I was able to shorten the development time. So instead of, something like that, it looks relatively simple when it's done. And that's the whole point. You want something really complicated to look really simple so anybody can use it. It also reduced the overheads to develop it by a huge amount. I mean, I can't even, if I had a bunch of 6-digit engineers or software programmers working on that, it would be so cost cumbersome that we're talking about, that's why you're finding $15,000 and $20,000 for analytics stuff. Nope, we were able to keep this on a list price because of the hardware and some other things, and then future tech support at under 10K. So, matter of fact, I'm not going to mention the list price on a system like this, but nobody else is coming close to that price for this type of technology. Also, it resides on your own system. You don't have to worry about a cloud-based system. I do not trust cloud. We all have to use it, but it is how the bad guys are getting in these days. If you get hit, you're going to get hit through the cloud normally, unless you open up something you shouldn't have. And they're getting really, really, really capable even on that end. A couple of times I got stuff and it looked like something that I was waiting for, and I go, okay, That's not a normal attachment, or that's not a normal this or that. Oh, I'm not opening that image, etc. Now I have my system set up. I even had somebody, a client, try to reach me with something. He says, I don't understand why my software is not getting through. I said, you better scan your system, because my stuff scans the files that are coming to me and will block any, viruses and the like. So, anything it recognizes, they're all sneaking by in one way or another. Anyways, I'm on another soapbox, but I wanted to give you an idea of what can be done. Part of this challenge, in addition to wanting to have a solely MotorDoc-centric product, from the software perspective, Empath is a partnership with Framatome ANP. MotorDoc, the Empower is very specifically ours. There you go. There's some other things that we're going to do with it when it goes out to protect our IP. It changes the world. I could have, and somebody has suggested I go out with a price between 15 and 20K, and I'm like, nope, that's not the point. I want the average person that can go in and clip on to a lead going to a motor to be able to analyze the condition of the machine in an inexpensive way with a high degree of accuracy, meaning better than 80%. So with that, thank you very much. Next week, I will show you some of the actual data from the city of Chicago and from the project we're going on, which will include fans. So we're going to fan work, and then the one downtown is on pumps. With that, have a great week, and thank you for watching this.